Hello, I'm Peter Moskowitz with Confluent, here to talk to you about the HTTP source V2 connector. Kafka is great at moving data, but the real magic happens when we integrate it seamlessly with the rest of our ecosystem. That's where Kafka Connect shines. Instead of writing custom producers and consumers for every system, connectors let us stream data in and out of Kafka with minimal effort. Think of it as plug-and-play data movement. A source connector can pull records from an external system like a database or an API, transform them if needed, and publish them to Kafka topics. On the other side, a sync connector picks up those messages and writes them exactly where they need to go, whether that's a data warehouse, a search index, or another application. Not all data lives in a database or a message queue. Sometimes the best way to get real-time updates is through an HTTP API, whether it's polling a service or integrating with a SaaS platform. This is exactly what the HTTP source V2 connector is built for. Instead of writing custom scripts to pull data from an API and push it into Kafka, this connector does it for you, efficiently and reliably. It can handle both GET and POST requests, making it versatile for pulling data on a schedule or receiving event-driven updates. The real benefit? It's simple to set up, scales with your needs, and adapts to different API formats. Describing an HTTP endpoint can get complicated pretty quickly. The HTTP source V2 connector supports the OpenAPI specification OAuth 3.0, which is a widely used standard for defining HTTP REST APIs in a structured format, often referred to as a Swagger file. By using JSON or YAML, it enables better documentation, automation, and integration with API tools, making it easier to describe, discover, and consume APIs efficiently. Secure API access is supported through basic, bearer, and OAuth 2 client credentials authentication. This flexibility ensures compatibility with both simple token-based APIs and enterprise-grade services requiring OAuth-based authentication. Client-side field-level encryption, CSFLE, protects sensitive data at the field level before it leaves the client, ensuring that even if the data is intercepted, it stays secure. And you define encryption on a field-by-field basis, so it's super fine-grained. Check out my video series if you want to learn more about CSFLE. At least once delivery ensures every API response is processed at least once, even if failures occur. This guarantees that no records are silently lost, though duplicates may need to be handled downstream. If an API request fails due to transient issues like rate limits, network failures, or temporary outages, the connector automatically retries based on configurable settings. Single message transforms, SMTs, allow real-time data modifications such as renaming fields, filtering records, or enriching messages before they are written to Kafka. These transformations are truly very simple, so if you need more involved data processing, you should consider more powerful tools such as Flink. Path variables enable dynamic API queries by allowing the connector to fetch data based on variable inputs. You can consider using this when pulling data by category, region, or any other parameterized filter. Template variables are very powerful too. They enable dynamic configuration by replacing values such as topic names at runtime. This approach provides flexibility, allowing your connector to easily adapt to different environments or datasets without requiring manual adjustments during each deployment. Many users of the original V1 HTTP source connector find it compelling to switch to V2 because of the simplicity and ease of management it provides. A single V2 connector can handle up to 15 paths exposed by the HTTP endpoint. You can associate each endpoint with its topic where the data will be published. Let's dive a bit deeper into how it's done. In Kafka Connect, a task is a unit of work that runs in parallel within a connector. Each task is responsible for processing a subset of the connector's workload, enabling scalability. Each task independently pulls its assigned endpoints on schedule, fetches data, performs transformations if any, and publishes the data to a Kafka topic. In our example, there's a one-to-one mapping between tasks and API paths. One task is allocated to employees, one for departments, and one for salaries. And a last word of caution, the days of the V1 HTTP source connector are numbered. If you're still using the V1, make migration plans over to V2 as soon as you can. Okay, enough talk. Let's see it in action with a demo. I'm logged into Confluent Cloud. Let's go ahead and create an environment for our demo. We'll call it HTTP Connector Environment. The Essentials environment type works for us. Let's create it. First thing we do is we create a cluster. The basic cluster option has some restrictions, such as limiting our connector to a single API path. These restrictions don't apply when using a standard cluster type or above. Since we want to experiment with multiple paths within a single connector, we'll create a standard cluster. After selecting your preferred cloud provider and geography, let's give our cluster a name and launch it. Now that our cluster is ready for business, we can go ahead and create our connector. Let's filter for HTTP source v2 and select a connector. After giving it a name, we have to point to our hosted Swagger file. Alternatively, we can also upload it. Confluent Cloud reads the config file, and subsequent steps of the creation experience are presented dynamically based on what our OpenAPI 3.0 descriptor contains. Our Kafka credentials can be provided in a number of ways. Here, I go with the service account option and check the Add All Required ACLs. On the top of the authentication screen, you can see the URL of the HTTP endpoint. As discussed earlier, our connector supports various authentication options. Our service uses basic auth, and since it was declared in the Swagger file, it shows up here for us. I'll enter my credentials to access the endpoint. This is the screen where you can also customize your SSL. We'll skip this step. Under Paths, we have 3 paths that our HTTP endpoint offers. Let's select all of them. Let's start with /. We can select an existing topic we want to publish data to, or we can create a new topic. Here we choose to create a new topic. We'll call it Credit Card Topic 1. No changes needed under request configurations. Under Settings, we can specify the offset mode. In case your backend data source supports pagination, our connector offers flexible methods to handle that using the chaining, cursor pagination, and simple incrementing methods. Check the documentation if you want to use pagination. Request interval is one of my favorite features. This setting allows you to control how much time passes between requests the connector sends to the HTTP endpoint. The default is 1 minute. You can easily speed up your data flow by reducing this value. And lastly, under Advanced Configuration, you find the client-side field-level encryption setting. There's an ever-growing number of managed connectors supporting CSFLE. Let's continue with the transactions endpoint. This service allows us to pass a parameter as part of the path. Here I am passing in 312. Since we are not going to use the summary and transactions endpoints, let's step back and uncheck them. And before we move on, let's do a quick test. This test will pull data from the HTTP endpoint the same way our connector will. Here, you can see that 2 credit card transaction records were returned. We'll skip single message transforms for now. We'll return to this step shortly. The sizing step shows the number of tasks this connector will start. Since the tasks and paths are mapped one-to-one, we see only 1 task here. Would we have kept the 2 other endpoints checked, we would see 3 tasks in the field, and the price would be 3 times higher as well. The last step allows us to review all our configuration settings. Switching to JSON and copying these settings will make it easy for us to create scripts and automate our processes. As the connector started, let's switch over to our topics. Here we see our newly created topic. Let's drill down and take a look at our messages. Here, you can see our first few messages. As you can see, the credit card information is all clear. Ideally, you want to encrypt any sensitive information, for example, by using CSFLE. But if that's not an option, masking it can be an alternative. Let's find the single message transform setting of our connector and mask the credit card number. I give the SMT a name, select mask field value as the transform type, and replace the credit card number field with a mask. And voila! No more clear text credit card data in our messages. And that's it. We have successfully set up the HTTP source v2 connector in Confluent Cloud to bring in external data to Kafka. Now it's your turn to give it a try. Thank you.